If you've ever taken a balloon and compressed it, you would have felt an increase in the outward pressure from the balloon. Or if you've taken in a breath, so you've increased the volume of your lung, then because of the decrease in the pressure inside your lung, you know the air is going to move in. Or if you've ever taken a flight and the flight's gone up quite quickly and you've got some sealed bag like a crisp bag, then you might have noticed the crisp actually expands, it gets bigger, takes up more space. This is because the change in the pressure as the cabin, inside the cabin as the flight goes up. So we're going to try to explain all of these phenomena using gas pressure today. So gas particles inside a container, they're moving randomly, and we know when they collide with the wall exerts a force on the particles, and the particles exert an equal opposite force on the wall, and this exerts a pressure on the wall at 90 degrees to the boundary of the wall. And if you take the force that the particles are exerting divided by the area, you get the pressure. So collision of the particles with the container wall causes the pressure. Here we have a sealed syringe with some gas trapped inside it. So at one end it's closed so the gas particles can't escape. I'm going to compress it slowly so the temperature doesn't change, but I'm reduced the volume. Let's say I have half the volume. What's going to happen to the pressure? So it turns out the pressure is going to actually double. So we call this an inverse relationship, and this is only true if the temperature is kept constant. We're going to try to explain why this is happening using words. So first of all, let's say as the volume decreases, the pressure increases, and that's an inverse relationship. We'll come back to that later. Why is this? Well, this is because the distance between the particles decreases. So that means they're going to collide more frequently. Or in other words, the time between each collision is going to be smaller, so they're going to collide more often in a given time. So if they're colliding more often, and also the area inside the container is smaller as well because we've reduced the volume, so there's less area over which the particles collide. Put this together with the equation of pressure, pressure equals force of area, right? So because they're colliding more frequently, there's more force, but because the area is smaller, and that's at the bottom of the equation, the pressure also increases. In this example, we're going to look at a student's answer and try to improve it, okay? So we've got a bubble here that's released underwater and it rises to the surface. As the bubble is rising, it's getting bigger. Explain how the pressure of the air inside the bubble changes. Assume temperature is constant. Okay, so we're not interested in the water pressure. We're looking at the pressure of the air inside the bubble. Basically, at the bottom is going to be a small bubble and it's going to be quite high pressure. And as it rises, the pressure is going to decrease and the bubble is going to get bigger. Okay, let's look at the student's first bullet point. As the bubble rises, the air particles get bigger. Okay, this kind of suggests that they think the carbon dioxide or the oxygen molecules are actually getting bigger. That's not true. They're just taking up more space. Okay, the particles themselves, the size don't change. The gas is taking up more space, or we can say the volume is increasing. Then the student has said the gas particles collide less frequently. Now this is true, however, they skipped a step. Then to explain why they collide less frequently. This is because it's taking up more volume, so the distance between the particles increases, and they're traveling at the same speed because the temperature is constant, so the particles still move at the same speed. They're going to collide less frequently. Okay, next they've just jumped straight to saying this reduces the pressure. We still need to explain a couple other points. We can link the force from the particles colliding and the pressure. We could say, first of all, the area of the bubble is getting bigger inside the area is getting bigger. And then you'd say pressure is force of area. And then finally, you could say this reduces the pressure.